First I am taking this, I am taking a copper wire, okay. I am taking the copper wire and attaching to the key, etc. The circuit, in the circuit board I am taking the simple, yeah, you can take this example also, our room itself, okay. Where is the main supply? Below the staircase, no. Below the staircase, just your below the staircase, you might have noticed a big main junction box will be there. These are all rooms, okay. So how many rooms there here in this thing? I think 3 rooms or 4 rooms. Maximum 5 rooms you can take. Okay, you could put it as 5 rooms. So the power is supplied from the main junction to these rooms. So what wire they will use? Normally they use copper. Normally they use for copper. So if they use copper, what is the advantage of copper? Why not they will use? Why not they are using for other wires?
Copper expands on heating.
No, that copper. If it expands for no, it's not about expansion. See, I'm having the this is the conduction. That is copper is well known for the conductor. Okay, copper. If the copper is well known for the conductor, what I have to use specifically. So in the same scenario, what do you have any other example opposite to copper? If you take any other example, why you can't use that material specifically, but you can use copper specifically? தமிழில் சொல்லனா ஏன் காப்பரை யூஸ் பண்ணுறாங்க ஸ்பெசிஃபிக்காக அந்த மெட்டீரியலை யூஸ் பண்ணலை? Heat loss, no, that's different. That and all different. Okay, that's different. Heat loss is different. Mainly heat loss, that and all not main specificity. Only thing I need conduction. If I fulfill the conduction, then I have to go for material. I have to take material. I am getting the conduction. Okay. What is the voltage that is normally get which current? You know that AC current. AC current 220 volts. Okay. That is the normal thing. So in the same scenario, so it has to fulfill all this criteria. Okay, so I am taking I'm having all the rooms will have the normally AC, refrigerator, etc. Entire home appliances. Entire home appliance means AC, television, color TV, etc., everything will be there. So if I fulfill the criteria, I will be using it. Okay, so in this scenario I am taking specifically copper. Okay, so now next is what I can ask one more question. If it is so, why I can't use iron and nickel? Because copper what is the atomic number of copper?
Copper is easy. The copper is easy.
Wait. No. What is the atomic number? Copper.
29, sir.
Copper atomic number. What is the atomic number of copper? Cobalt, iron, nickel, copper, zinc. 29. What is the next criteria? Or below? What is below that? Yeah, you can take nickel. Okay, nickel is 28. Okay, so nickel is 28, copper is 29, zinc is 30. Okay, copper, nickel, copper, zinc. 3 criteria, sir, but I am taking copper. Then why not I take nickel? Anyone you can take. Anyone out of 3? No, not nickel you can take. Okay, something nickel. So I am taking specifically nickel, but I am not taking nickel, specifically nickel. Not specifically I am taking copper. At least you understood the question.
Yes, sir. Copper is used.
No, wait. When I asked it, did you understand my question?
Yes,
okay.
Sir.
See, what is the atomic number of nickel, copper, zinc? 28, 29, 30. In that specific, everybody knows that. Everybody knows that. If we need, everybody knows that. The entire home appliance is made up of copper wire. My question is that why copper wire? If they are using copper wire, why not nickel? Nickel, you can use nickel wire also, no? You can use nickel wire also, no? Instead of using nickel wire or zinc wire or something nickel wire, they can use. It's not about the it's not, so instead of using nickel wire or something like that, specifically they're going only for the copper wire. That means it has the good conduction. First it was the good conduction. That's the main thing. It has the specific property. That's a specific property of the copper. That means it will fall under the conductor. It will fall under the conductor. So that means if they fall under conductor, that means what is a, so AC voltage. So what is the voltage I am using is 220 volt. 220 volt and 5 amps and 15 amps. Okay, maximum you can take as 15 amps. Not cross 15 amps. 15 amps crossing the 220 volt. Okay, main power supply is there. Main power supply is there. So from the main power supply to the wherever they needed, it will be passed all the current that passed is, it will have the 15 amps with 220 volt. There is not be voltage drop. That means the voltage is not what is we are supplying will not be dropped in the copper. That means it shows a very good conduction. It's a very good conductor means it has to pass the current frequently. Correct, exactly there should not be any loss of the current. Okay, if there is a loss in current, what it will lead to? If it is loss in the current, it will lead to the heating effect. That is the heating effect. Heating effect means the current that we are passing from one point to, I am taking this one point. I am taking one point. This is copper wire I am taking with length L. Okay, P1, P2. Okay, so I am taking one wire, copper wire. Okay, I am passing the current. Okay, I am passing the current from one point to another point. Okay, so when this current is passed, what is the output? When the point that is the current that is passed, let us assume it is 15 amps. Here also 15 amps. The current should be 15 amps. Here if it is the 15 amps, instead of that it is 5 amps, means what is the first possibility? First possibility is 15 amps and 15 amps. Second possibility is 15 amps, 5 amps. So what happened to second possibility? What is the contrast? Loss of the current. When this loss of the current, what it immediately led to the when the current is lost means immediately led to the heating effect. So heating effect. So that's the Joule's law. What is Joule's law tells that? Joule's law of heating. When there is any power, when the material will lead to the heating effect. When the material will lead to the heating effect. So now I am having the two possibility. One is there is no current loss. Another is current loss. Okay. If there is current loss is there, immediately the if there is a loss of current means, if there is loss of current means immediately it led to heating effect. No heating effect. So which will I will prefer? One or two? That's all. Which will I will prefer? Which one or two? Huh? How many people tells one? How many people tells two? First one I am taking the any material I am taking. One material I am taking it. Okay? I am taking one material. Okay? I am passing the point 1 and point 2. For point 1 I am passing 15 amps current. For point output is the 15 amps. Same, no loss of current. No loss of current means no heating effect. Now I am in the second option I am going 15 amps. 15 amps, but I am lost, but output I am getting only 5 amps. So there will be heating effect because the current is lost. So which one I will go for the home appliances?
First.
Who is telling first one? Then everybody is agreeing. So then who is telling option 2? Nobody is telling option 2. Yeah, it's the first one obviously because I am taking the copper wire. Okay. If I go for the heating effect, what will happen to the wire? Melt. It will try to melt. This based on this criteria only, they will choose all the home appliances material. They will choose all the home appliances material. Okay. So I have fulfilled the criteria. Okay. I have fulfilled the criteria. Now for that only I have chosen the copper. That's the main reason why the copper is there. Compared to nickel or zinc. Compared to nickel. So everything was rejected now. There is no room that the nickel, zinc will become into effect. So only thing is that you need a copper. That's all. The copper is there. It showed the no current loss. So no Joule's law, no nothing, no heating, nothing. No heating and nothing. Okay. Now if I go to now I am going to water here restroom. Everybody knows that in restroom the heater will be available. Okay. Heater will be available. You will switch on it and heating for half an hour. Maximum half an hour you can keep. Okay, then switch on it, you will get a hot water. So what is principle behind that? Yeah, second one. That is a heating effect. So for that, which material I will be using it? No, it's not a copper. This is only copper. Iron, specifically iron rod. So specifically iron rod. Okay, specifically iron rod will be used to heat the material, specifically water. So that's why. So there I used the iron. There I used the iron. So iron means which will come under which category now? Second category. Okay, second category means iron will come in the second category means what is the co-runner of iron?
Hematite.
Hematite. Co-runner of iron. You understand my question? Did you understand my question? I need a heating effect, which is heating the specifically for the heater. Specifically a heater, I want to heat only water. Okay, a specific heater, I want to heat only water. Okay, so for that I add the heating material. What specifically I will use it? I can so in the same series, what I can replace the material. Specifically I used this. No, heating effect. That's no, specifically used this heating effect. Which material I will use it now here? Iron. Now that is the thing. So if I want to replace the iron means that's a core runner. That means a material is there. I want to replace with some other material. So which I have fulfilled the whole criteria. It should be what it should be. That means you didn't understand about the atomic number. What is the atomic number of what is the atomic number of iron?
26.
26. For nickel? 28. So for nickel is for iron is 26. For nickel is 28. In between is what?
Cobalt.
Cobalt 27. So 26, 27, 28. So there is some there is water heater is there, which is having iron as the rod. I want to replace with cobalt, but I can't replace it. I can replace it, but it will be expensive. So for iron and cobalt both are water heater, both are heating material. In the cheap is iron. So the people will be the cheap is iron. So people will prefer for iron rods. That's all. So since the cobalt will possess same property, but it will be expensive. So we'll go for iron. So now I am taking the conduction. Oh, we're going for conduction, no? Conductor. Yeah, conductor. So the conductor is, it should have a high conduction. So high conduction means it should have low resistance. So how the high? So did you understand this? To this part you didn't understand. Okay? Do you have any doubts?
No, sir.
Okay? So because I am having some materials. I am having some material which is conduction. So the conduction means it should have very good conduction. Okay? If it's a very good conduction means what happened to its resistivity? Resistance should be low because conduction and resistance are inversely proportional. If any material I am having if any material I am having very good conduction, it should have low resistivity. So for now I am going in the same series, I am going for insulator. Insulator will have the high resistance. No, insulator. High resistance. Then it will have the high resistance will have the what conduction? Zero conduction. No conduction. Zero conduction or low conduction. So this is what the separation of conductor, semiconductor and insulator. Now we comes the concept of semiconductor. What semiconductor? What is the definition of semiconductor? What do you think? Just definition. What do you think that what could be the reason of what could be the semiconductor? What is conductor? No, it's having high conductance. So insulator will have a low conductance. So semiconductor should be moderate. In between, it will not allow, it will have only few percentage of conduction. That means it will have both. It will have the in between the conduction and resistance. So it will have the 50% of conduction and 50% of resistance. So this is 50% of addition in between conduction and insulation. So what makes the conduction more? What makes the conduction? So in that series, now we go for conductor, semiconductor, insulator. So conductor is the valence band. So the valence band and conduction band. In the valence band and conduction band, valence band is the one by which from which the electron will be jumped to the conduction. Okay, conduction band is the one which will absorb the electrons. Okay, it's very new to you.
Yes, sir.
I am from a faces of I identified. It's very new to you. Okay, valence band and conduction band. Okay, conductor is there. Okay, conductor. First one is conductor. So conductor, valence band is a one which will from which valence band is a one where electron is available. Conduction band is a one which absorbs the collector, will accommodate the absorbs or accommodate the electrons. Okay, so the valence band in the conduction band there is no gap. That means the valence band and conduction bands are overlapped. Valence band and conduction band overlapped. Overlapped means electron which is present in the electron present in the valence band can move to the conduction band. So can move towards the conduction band. Okay, without any external effect. That's why copper is conductor. You understand my question? Valence band and conduction band valence band is the one where the electron will be available. Okay, and conduction band is the one where the electron will be accommodated after the conduction. Okay, so the valence band and conduction band is overlapped means the electron can move freely from in any place from the valence band to P1, P2, P3. Where is P1 here now? Valence band. P3 valence band, and P2 is conduction band. So the electron can move from valence band to conduction band to valence band. That means it can move freely. That means, so example, what is the example of this conductor? What is the example of this conductor? Copper. That's why copper is example. Okay. Okay. Now I am going to insulator. Insulator is what is example for insulator? Glass. Will it conduct current? No. So it will not conduct current. Why it is not conduct? This one is a valence band and this one is the conduction band. So in the valence band and conduction band, what is the gap? That gap is the energy band. The energy band is very high. The electron cannot jump from valence band to the conduction band. So what is the value of energy gap now? What is value of energy gap now? Eg is greater than 3 electron volt. The Eg is greater than 3 electron volt. So example is glass. That means glass, in a glass, the gap between valence band and conduction band is what is energy gap between energy gap? What is it?
Greater than 3 electrons.
Greater than 3 electron volt. Greater than 3 electron volt. That means what could be the value of now energy gap in glass? Wait. Who is telling? Who is telling? What is the energy gap in the glass? That's all. What is energy gap in the glass? Who is telling?
3 electrons.
Who is telling now? And why? Who is telling and why? Yeah, come on, who is telling? Who wants to tell? Who wants to tell? Glass is well known for insulator. Everybody knows that. Now, what is the energy gap in the glass? What could be the value? Somebody has to tell. Okay. Who's telling now? Did you understand my question? Glass is insulator. Okay. Everybody knows it will not conduct electricity. Okay. Current will not conduct current. Why? Because the energy gap is. Okay. So what could be the value of energy gap in glass? If you understand this, you have understood everything. Who is telling? Who is telling? Now, why are you showing a hand to him? If you want, you tell. Who is telling? Yes, suddenly tell some value.
Eg greater than 3.
What is the value, exact value? What could be the value? What could be the value? What could be the value of in glass? I am taking glass, okay? Taking the glass, it could be this value.
More than 3 electrons.
Huh?
More than 3 electrons.
Exact value கேக்குறாங்க.
No, it's not.
இவங்க சொன்னாங்க.
So in that case, what could be the value?
3, sir.
It could be what?
3, sir.
Yeah, correct. 3.1. This is what I asked you. 3.1. Why it is 3.1? Because energy gap is greater than 3 electron volt. So what value I can substitute so that it could be more than 3 electron volt? What value I can substitute Eg so that more than 3 electron volt? It could be 3.1. That's all. Because I can substitute also 3.05. That's a low value. 3.1 is the optimum value. So if I substitute 3.1, it could be 3.1. It could be more than 3 electron volt. That's all. That's why. So the value of glass, energy gap in the glass, it should be minimum 3.1. It could be 5 also. That we least bother about that. It could be 6 also, 7 also, 8 also. Everything we least bother about it. It could be more than 3.1. So that's a value. That's why it's insulator. That's why glass is insulator. Now we comes for the semiconductor. What could be the value of Eg now?
Less than 3 electrons.
So what could be the value now?
2.9.
2.9. So if the value lies in the 2.9, it's a semiconductor. It's a semiconductor. That's all. So that means semiconductor means its value should be, the energy gap should be around 2.9. It will be less than 2.9. If the less than 2.9 means what? It could be 1, it could be 2, it could be 2.5, it could be 2.7 or 2.9. Anything less than 2.9, less than 3. Less than 3. Yeah, less than 3. So it should be 2.9. So did you understand now? So in this, so now this semiconductor. So then why I need semiconductor compared to conductor? I can use directly conductor, no, because semiconductor only conducts off. It conducts off. So what is the special difference? Now you forget about insulator. Insulator we need not discuss. We don't need hereafter insulator. Hereafter no need for insulator, nothing. Just conductor and semiconductor. In what specificity I use the semiconductor? Semiconductor is a one, it has both, it has only conduction, no resistance. But where you need the resistance and conduction both, there you need the semiconductors. So now only there comes the application of the semiconductor. Do you want to take this value? Sigma for metal it is sigma is 10 power 8 Simon per meter square. For metals, sigma. What is sigma? Sigma is the conductance. Conductance is equal to 10 power 8 Simon per meter. No, Simon, conductance, meter square. Simon plus meter per meter. Simon plus meter. For it is semiconductor, it is 10 power 5 Simon per meter. For insulator, it should be 10 power minus 10. 10 power minus 10 Simon per meter. Insulator. Now we are going to see only semiconductor. So semiconductor has the two types, intrinsic and extrinsic. So semiconductor has two types, which is intrinsic and extrinsic. Then extrinsic has two types now, N type and P type. N type extrinsic has two types, which is N type and P type. Now what is specialty of now extrinsic? Extrinsic is the one what is difference between extrinsic and intrinsic? Extrinsic what I told, extrinsic and intrinsic. Yeah, intrinsic is the naturally available semiconductor, which we don't want. Intrinsic. Extrinsic is the one, extrinsics are two types, which is N type and P type. That is what we needed, which is synthetically made in the lab. Synthetic, that's a natural, this is artificial, okay, which we need it, okay. So why we need it? That's why. Do you have any idea why we need the semiconductor now? Semiconductor, why we need it? We don't need we don't need intrinsic semiconductor. We need only extrinsic semiconductor, which is P type and N type. N type, because what we need it means we need which we can utilize in the whole applications, like in something applications, okay. If there is no naturally available as no application, okay, so we neglected it, okay. We need, because we need to put into what for we are doing all the semiconductor. What we are doing for why what were the purpose of this all semiconductor? What for we need it all the semiconductor? All semiconductor industries, which is it's having application in all over from the mobile phone to PC, laptop, mobile phone, iPad, laptop, everywhere is the semiconductor industry plays a role. Everything is market, everything is money. We need money, okay? We're going to invest money in the mobile phone industry, okay? We're going to produce cheap one. We're going to invest for one mobile. For example, any mobile if you take, we're going to invest cheap of the money, money we're going to invest, and we're going to take 10 times. For example, if there is a mobile phone is cost 10,000 rupees, total amount involved is not more than 1,000 rupees, okay? So 1,000 rupees is there, then you have to pay tax to the state government, central government, 1,000. So 1,000 rupees is manufacture cost, its cost, 1,000 rupees is tax, state government, central government tax, then 1,000 rupees for the for industrial purpose and labor, etc. So 5,000 rupees I spend for 5,000 rupees I spend for the smartphone, okay? I will be selling it outside 10,000 rupees. So how much I got it now, money? Huh?
2,000.
Twice the amount. I got it there, twice the profit. I sold it for 5,000 rupees. 5 into 2, 10. So twice the amount I got it. You have to tell in the twice the value, not the money, total money. Something at twice. That means if I spend 10,000 rupees and I got it money 20,000, sold it for 20,000 means twice. So now I am going for iPad. No, again I am going for, I will be spending minimum, all the total amount that I will be spending it 5,000 rupees, 50,000 rupees. But I will be selling in the outside for 2 lakhs. So 2 lakhs, something like that, okay? Let us assume 50,000 I spent. So how much profit I got it? 3 times. 3 times. So 2 times, 3 times, this and all profit, okay? Industry profit, money. So what is the money I am getting it? What are the money I am spending it? I got it that 3 times profit of it, okay? Like that. So in all the semiconductor industries, all the semiconductor industries meant for only for business, market, profit. Okay. Now I am going for extensive semiconductor, which is N type and P type. So N type means what is the definition of, do you know hole? What is hole? What is hole? Hole cannot be negative charge. How hole can be negative charge? It's not a neutral. What is hole? What is hole? What is hole? Huh? It's a positive charge. Hole is a 1. Hole is a 1, will be positive charge. Electron is a 1, negative charge. So if the hole is, electron is sitting here, jumped to another hole means it is now here, what is the charge here? Positive. This one is electron is in the negative. So negative and positive will constitute the neutral. So 0. Here charge is 0. Now the electron is going, now electron is jumping to another hole. Okay. So, if the electron is jumping means there now the what is it? Neutral charge. Why it is? Because electron is present there. And the holes is present there. Electron is present in the holes. So electron is negative charge. Hole is a positive charge. So that what is the overall charge there? 0. Yes, 0. If electron is present is 0. If electron is not present in the hole, what will happen now? What will be the charge? Yeah, it should be positive, because if electron present is become 0, if electron is not present, it will be 0. No, it will be positive. It will be positive. So 0 and positive. So 0 and positive. So this is the what? This is the what? The industry. So now comes the N type and P type. The N type means it has the excess electron. P type means it has the excess holes. Now you know semiconductor, okay? Semiconductor between valence band and conduction band. So when the conduction band, what will be the energy gap between it?
Less than 3 electron.
So less than 3 electron volt means it should be probably around 2.5, 2.9 or 2.8, 2.7, 2.6. Okay, we will keep as 2.5. That means if the energy gaps are around 2.5, yeah, energy gap is around 2.5, then it falls under this region. So this will fall under this. It will fall under the semiconductor. Now what is the n-type? N-type means n-type. What is n-type now? You know very well. What is n-type? Excess electron and excess hole. Okay. Now what is the energy gap? Now this is the energy gap. Okay. Now what I am doing is after doping, I am doing doping. What is the material for example for what is the example for semiconductor? Example. Yeah, doped silicon. So what dope? Any dope you can use? Do you have any specific dope? Doped silicon. I am taking silicon. Okay, I am doping it. So if I doped even silicon nitrate. Okay, silicon nitrate is example for the doped silicon. Okay, now adding impurities. Doped na silicon எடுத்துட்டு if in other words if you take other words எப்படி சொல்றதுனா silicon எடுத்துட்டா again it will be insulator. அது கண்டக்ட் பண்ணாது. doped silicon பண்ணினா அது வந்து இன்சுலேட்டரை வந்து கண்டக்டரா மாத்துறது. ஸோ சரி doped சிலிக்கானை எடுத்து கண்டக்டரா மாத்துறதுனால அது வந்து இது கண்டக்ஷன் அதிகமாக இருக்கும் தெரியல, அது கண்டக்ஷன் அதிகமாக தராது, ஒரு ரொம்ப கம்மியாக தான் தரும். ஆனால் இன்சுலேட்டர் ஆக்சிடென்ட் தான் சிலிக்கான் வந்து இன்சுலேட்டர். But doped பண்ண பிறகு what will happen? It will show the conduction in the, but it will not show the high conduction. It will show the conduction less than almost half of the conduction. So that's why so after that only they introduced the concept called semiconductor. So normally what they taken is silicon nitrate. So silicon எடுத்து they doped with they added impurity to the nitrogen. So it becomes the now silicon nitrate. So silicon nitrate is a semiconductor now. When the silicon shows when the silicon is insulator, when the nitrate is become, it showed the some conduction, not full conduction, some conduction. So they showed that it's an insulator, but it's not showing full conduction like copper. Copper is the one which shows the full conduction. But the silicon when doped with the nitrate, it didn't show the conduction equal to simple to copper. So what we can name it as semiconductor, because it's showing both the property. It's showing the conduction, it's showing the insulator property as well as the conduction property. So hybriding it is called the semiconductor. After that only they introduced the concept of semiconductor. So then then they found out the energy gap. What could be the difference between the conduction is due to energy gap. Now comes the n-type. N-type means excess electron. So excess electron means what you can do when the silicon is doped with nitride. So two types of nitride and silicon phosphorus, etc. The silicon nitride is example for n-type. Silicon phosphorus is example for p-type. So how will you differentiate n-type and p-type? The silicon nitride they taken it and doped it. So now what will happen? Now this is, you know very well, valence band and conduction band. So I want to show the energy gap is the energy gap will fall into this range. Now it should have the n-type. N-type means it should have the excess electron. So what I can do is I can shift the valence band from between towards the conduction band with energy gap of 0.01 electron volt. Now what is the energy gap here? 0.01 electron volt. If the band gap is around 0.01 electron volt, what will happen? Now it shows the n-type semiconductor. In n-type semiconductor, the valence band is shifted towards the conduction band. Now in the p-type should have the excess hole. So what is this doing that? The conduction band is shifted towards the valence band with energy gap of 0.01 electron volt. So when the band gap, only option is to move the valence band and conduction band. The band difference, only option is to move the band gaps from valence band to conduction band. So the directly if directly it cannot be moved because the energy gap is very high in the semiconductor. Okay, what is the energy gap here? Semiconductors? less than 3 electron volt. Now I am passing it, now I am shifting the valence band towards the conduction band with energy band is 0.01 electron volt. So now the, what is the band gap now? 0.01 electron volt. Here again I am doing it for the p type. For p type I am shifting the conduction band to the valence band. Energy band gap is 0.01 electron volt. So that means I am shifting the band gap. I am shifting the band gap, valence band gap to the towards conduction and conduction band towards the valence band. So finally what is I am doing is so now I get the n type and p type. N type is the excess electron, p type will have the excess holes. So do you understand this concept?
Yes, sir.
Who did understand? Do you understand all the concept? Who didn't understand? So now the two types of semiconductor we got it. One is n type, another is p type. So now if I in n type what will have the excess?
Electron.
P type what will have the excess? Holes. So how the what is the energy gap between the valence band and conduction band in n type? It should be 0.01 electron volt. Here it should be in p type. The valence band, the energy gap between the valence band and the conduction band should be
0.01
electron volt. So in p type, which is shifted?
Conduction band.
In n type? Valence band. So by shifting only we can change the energy gap. Now it shows the now it becomes the semiconductor. That is insulator become now the semiconductor. Semiconductor is not a fully conductor. So that's why it's called a semiconductor. That means it will have 50% of conductance property, 50% of the insulator property. Now PN junction. When I go for PN junction, what will happen now? When you will get a PN junction, P is the one will have the highest holes, N will have the excess electrons. So that means I am combining the PN junction. If I join it to the PN junction, what will the total value now? It should be PN junction. If I attaching it, what is the charge will be now? It should be neutral because I am attaching the P junction and N junction. If it is only P junction, it will have excess hole. If I have only N junction, it will have excess electron. Now I attach a PN junction means the overall charge should be 0. So in this now we are going for forward and reverse PN junction. So the PN junction has the forward bias and reverse bias. It has both forward bias and reverse bias. If in the forward bias, if the voltage increases, if the current increases, the voltage decreases. In the reverse bias, if the voltage, current increases, increases. Then PN junction has a special property of Zener diode. So Zener diode. So what is the application of Zener diode? It can use as a inverter. That means it can use as a inverter. In the what happened in the PN junction, reverse forward bias and decreases. For reverse bias, no, for forward bias, voltage decreases. If you use a Zener diode, it will make opposite of it. If you make opposite of it, so what is the opposite of forward bias now? Voltage increases. Then in the reverse bias, voltage decreases, conduction increases. So that's you have to make the reverse of that PN junction. That's a Zener diode. Now application of the junction diode. So now we are seeing that application of the junction diode, that is P and N junction will constitute either PN junction or diode junction. Okay. So this diode junction has a two application, which is photoiodide, light emitting diode, and solar cell. Three types, three application. What is the three application? Photodiode, light emitting diode, and solar cell. Solar cells. So in this three application, you know, right? What is application of solar cell?
Provide solar energy.
No, it's solar energy. What is main principle behind it?
Light energy into electrical energy.
Light energy into electric energy. That's why I asked you. When I ask one question, you have to tell very narrowly what I am expecting it. Okay? Solar, everybody, just I think in last class I told us something. Last class what we discussed? No, not last class. Yeah, last class. No, something physical world. Before that unit measurement, before that law of motion. Somewhere I told you that solar application. Solar application. Solar application. So solar application is a specific. Okay, specifically I need to convert solar sunlight or sunlight into electrical energy or electricity. Okay, so for that purpose, no, before that for that purpose we will use the specifically PN diode. Okay, so in that first one is what we use photoiodide. So for the photodiode is used in the normally for the instrument. In the instrument only they will use optical signaling. For optical signaling, for optical signaling, it's it's mainly used for the based on the optical instruments. So what is the based on the optical instrument? What is the based on optical instrument? Based on the optical instrument. For measuring the vision of the, what is your eye power, total eye power? For everybody, for normal. Eye power is normally for everybody is 6 out of 6. 6 out of 6. If you have any defect, it means what it will be? You have to wear specs, right? So you have to wear specs. So if you wear specs means what happened to your vision power now? It should be around 3 or 4. You lost the total value. It should be 3 or 4. For measuring your, so how will you measure that? How will you measure? Yeah, you can see the from here, you can see the wall, and you can see that if everything goes fine, no problem. You are having 6 out of 6. So I can't see it very well means I have to wear the specs. So how can I measure the value? Based on that, it could be low value. 2, if it is less than 6 means 5. It could be around 3 or 5 only. If it is 5 means okay, 3 means very low. So I can't see it very properly. So all this, so it will be used in the optical instruments. Then is second one is light emitting diode. Light emitting diode. What is main application light emitting diode?
LED TV.
LED TV. LED TV, full principle is based on this only, LED TV. That's why what is a normal TV and what is a normal TV versus LED TV? It will be flat. So it will be flat. That's a main application. They will tell it's a LED TV. Okay. So they will tell that it's a LED TV. It will be flat and you can stick it towards the wall. Ordinary TV you have to keep the stand. But instead of that you can keep it in the wall. So that's the application of LED TV. Now third one comes the solar cell. So the solar cell means junction diode is there. Okay, P junction and N junction is there. Between that light will fall on it. So when its light is fall on it, what is the output here? When this is a solar cell, light is falling on it. What is the output there? Electrical energy or electricity. What is electricity? Electricity is current. Current is electricity. What is current? Flow of electron. So I am passing this is a junction, PN junction. So in the PN junction attached to here here it is a P junction and here it is N junction. What is a P junction will have? P junction will have lot of holes, excess hole. Excess hole means just one hole is sufficient. The one hole also excess only. It has total number of hole, that is the total number of hole. Here so excess hole. Here the N junction which is excess electron. So that means that is constitute the solar cell which is PN junction. So if this PN junction is there, what I'm doing is I'm flashing the sunlight, specifically sunlight. I'm keeping the top of the house and keeping the specifically sunlight. So that means the moment the light fall on it, when the moment light fall on it, immediately what I will get outside and current, outside I get the current which is electron. That means flow of electron. Electron get flowed. So if the junction is this, what is the junction here? PN junction which having excess hole and excess electron. So now outside flow what I am getting it? Flow of electron. So which should be now which should be excess now? N type. N type should be the excess. That means electron should flow continuously. And P what happened now? P type? P type decreases. P type decreases, N type should increase so that electron will flow outside. That means once electron flow outside, flow of electron is nothing but current which is electrical energy. I will get current outside. Yeah. Now another possibility. We have taken now NP junction, okay, or PN junction. Junction we have taken it, okay. Now we are increasing the two possibility. I am adding PNP, then PNP, NPN, PNP. So NPN means it has two N type. Two N type is connected to one P type. Two P type is connected to one N type. Now which is dominant here? Which is dominant here? N. So 2N is connected to 1. So which will have more here? Excess electron. As such P and N will constitute? No. Who will tell? Huh? Which is excess here? Which is dominant here? Which is dominant here? One person should tell. Any one person. Wait. Who's telling? Who's telling? Which is dominant? Okay. Dominant is N here. Dominant is P here. If N is dominant, what will have the charge? It should be? Yeah, electron. That's all. That all I'm asking. It should be excess. Dominant is N. So dominant N means what it should be? It should have electron. So electron is dominant means what is the charge? Negative. Here it should be dominant is P. Ball. So whole. No, that's it. Dominant is P. Whole means dominant is P means dominant is whole. It should be. So this charge, this junction will N junction will dominant is negative charge. P and P junction is dominant is positive charge. So, emitter base collector, you know, right? Emitter base collector. Emitter one which emits the electrons. Okay, collector is the one which collects the emitted by the electron is absorbed will collected by the collector. Base is the one that connects the emitter and collector. Then emitter is equal to I is equal to IC plus IB, that is current emitted is equal to current collector plus current of base. So I is equal to IC plus IB. Now you taken this? I will drop. So I am applying this one is P and P junction. Output is current. Output is current. Okay, what current is this one? NPN. Okay, this one is I current. What is I current? IC. IC is conduction current. IC collector current. This is one is collector current. This one is a emitter current. Okay, so I am applying the voltage here. NPN. This one also same collector current. This is one the emitter current. So I am applying the voltage. So which I can expect more current compared to this two, A and B? B. Why? The excess no. So the excess the NPN junction will constitute the current output. There also current will be there, and this current will be B is greater than A. So in solar cell, or now we go for solar cell. Okay, the solar cell, this junction if I am using, which junction I will use?
B type.
B type, because the B type will have the more current flow. The B type more current flow. So that means so I can use instead of this junction. Out of two junction I will go for NPN. Now next one is common emitter transistor. So transistor, now it has a common emitter transistor, which is CET. So in this common emitter transistor, what is the thing is, I am applying the input resistance. Okay, input resistance, output resistance. So RI, this one is RI. So input resistance is equal to delta V by delta I. B, what is B here? What is B? BE. Any one person? BE. Base and emitter. Why are you blinking for like this? Just now I told you base, emitter, collector. Collector is emitter is the one which emit the current. Collector is the one which collects the current. Base is the one acts as a connect the both emitter and collector. So it should be BE should be base and emitter of voltage is divided by current of the base at constant voltage CE. What is CE here? Collector and emitter. So the input RI is equal to this. Then RO, what is RO? RO is the output of the expected CET. So which is delta VC divided by delta IC at constant IB. Now transistor no, you taken this?
Yes, sir.
Now transistor is can be used as a three ways: as a switch, as an amplifier, as a switch and as an amplifier.
switch.
First one is transistor as switch, another one is transistor as an amplifier. So, on the transistor switch V0 is equal to VCC minus IC RC, which is output voltage. Total output voltage is equal to total voltage minus IC. IC is the, what is IC here? Current. R is the resistance. Then when a transistor is used as amplifier, AP is equal to beta AC into AV. AP is equal to power gain, beta AC is the current gain, AV is the voltage gain. You taking this?
Yes, sir.
Huh?
Yes, sir.
Now we go for logic gates. Logic gates are 5 types. First one is NOT, another one is NOT, OR, AND. So if you combine NOT and NOR, NOT and NOR, NOT and OR, NOT and OR, you will get, what you will get? NOT. Then if you combine NOT and AND, you will get NAND. So if the NOT is nothing but, what is NOT? You know? NOT is, yeah, not A bar, NOT is the inverse, nothing but inverse. NOT will give the input if the NOT will give inverse of input. If the input is 0 means inverse of it should be 0 and 1. Okay? If it is inverse is if input is 0 means output should be 1 because inverse. If input is 1 means 0 is output is 0. Now then second one is what we got is R. So R is for R and for OR, what is I have to do? Two input should give one output. For AND also, two output should give one input. No, two input should give one output. So if this is the case, first one is first one we go for R. In the R, what is the 4 possibility is there means because two output. Two output means 4 possibility 0 0 0 0 1 1. Here it is 0 1 0 0 0 1 0 1 0 1. So what could be the output? What could be the output of if it is 0 0? Or in this value, 2 value we will take. Just 2 value. Okay. First one we have first value and fourth value will take. What is the first value? First value should be 0 0. Fourth value should be 1 1. So if first value and fourth value 0 0 1 1 means what is the output for it? It should be 0 and 1. How it is 0 and 1? 4 value is there. Okay? You need not go for 4 value. First value and fourth value you can take. Okay? First value should be 0 0. Output should is 0. First fourth value is 1 1. Output is 1. So why it is 1? You have to take maximum value. Maximum value of 0 is 0. Okay? 0 0 0. Then 1 1 is maximum value is 1. Now we go for now we go for AND gate. Similarly in AND gate 4 possibilities there. 0 0 0 1 1 0 1 1. You have to take just first and fourth value you take. You need not go for all four value, first and fourth. Okay. So what is the value of first one is 0, fourth is 1. So why it is 0 and 1? Again you have to take maximum value. 0 0 maximum is 0, 1 1 maximum is 1. Now we have to take now NAND and NOR. Okay. First we go for NOR. Okay. NOR if we go two input which is 0 0, the same four input 0 0 0 1 1 0 1 1. So what is the corresponding should be? What is corresponding should be, and what is for the NOR? You understand my question? You didn't understand? No, you didn't understand. Okay. First you go for OR gate. Or in OR you have the four possibility 0 0 0 1 1 0 1 1. Okay. First in that four value just take first and fourth value, which is first and fourth value, which is 0 0 and 1 1. For OR gate what is output? 0 0 0 1. For OR value it is 0 1. And what is NOR? For NOR value what should be?
1 0.
1 0. It's inverse. 0 1 you have to make a inverse of it. So if you make inverse of it, it should be 1 0. Now we are going for NAND. NAND it should be who is telling for NAND? First you have to tell AND, then you have to tell for NAND. Everything you have to tell. Who is telling? Who is telling?
1 0.
Yeah, who is telling? Who is telling? Who is telling for NAND? First you have to tell for AND. You have to take first and fourth value, and you have to tell it for now NAND. Who is telling? Tell.
And first value 0 0. Fourth value 0 1 1.
1 1. So what is the output?
0 1.
0 1. For NAND it should be
1 0. Output.
No, for NAND it should be
1 0.
1 0. Inverse of it. Now we come for IC chip. IC you know integrated IC integrated circuit. You know very well it's meant for TV. Okay, it's meant for TV, and it is of two types, linear and digital. Okay, so you know very well nowadays only linear or monolithic. Okay, linear or monolithic or digital. Now you know very well digital it's available in the TV, in TV. All the TVs is available in the TV. All the TVs nowadays all the TVs nowadays available which come under which category now? You know, right? You know or no? All the TV. No, it's not about LED. LED is advanced. You do not go for LED. Okay, advanced, very very advanced. Two types of television. Nowadays, two types of chip is monolithic and digital. Okay. Now all the TVs will fall, which is available now, will fall into monolithic or digital. But why will not follow to monolithic? Monolithic is a one of colored black and white. That is not coming now. I think this black and white it's vanished. I think black and white. No TV is coming in the black and white now. Everything is vanished. When it is available, you know?
90s.
In 90s only it's available. At the time the chip used was a monolithic. Okay, monolithic or linear. Okay, now it is digital TV. But if it is so, what is the advantage of monolithic versus digital?
Colors.
Yeah, coloring process. The coloring process which you can see, the coloring picturization, everything you can see, coloring process. There it is not, there is no coloring process. So only black and white. So black and white is only two types of color. Okay, here it is variety of the colors. So several, which is our WebGR. What is WebGR? WebGR. Uh, Read. Yellow, etc. So totally how many colors you have in WebGR? 7 colors. So digital TV that you are seeing only fall into the 7 colors. So this is the 7 colors. So that's the application of digital versus black and white. No, digital versus black and white, monolithic IC. So that's the application of this IC by which you can see varieties of the colors. Okay, okay. That's all over. That's all over. Who is telling? Who is telling?
Check background.
Now we're going to see an important, good day. Now we're going to see an important chapter in the NEET physics section, that is nuclei. So the nuclei means, is how the nucleus, how the electron and the nucleus constitute the entire structure of the of matter. So that comes the main key role in this nuclei. So the nuclei generally can constitute the proton and neutron. So how significant is the proton and neutron to this chapter, that we are going to discuss now in detail. So that's the main importance of the nuclei, which is important chapter in the NEET physics session. So now we go for nuclei. So the nuclei means, the moment nuclei means, you know very well, right? Nuclei, what constitutes the nuclei? Nucleus, nucleus. So the electron is surrounding the nucleus. So the nucleus is constituted, a constitution of nucleus is proton and neutron. Electron. Proton and neutron. So the proton and neutron constitute the nucleus surrounded by the electrons. Okay, surrounded by the electrons. The electrons are negatively charged. So what is that? What could be the charge of proton? And what is the charge of nucleus? It should be positive. So if this is positive only, it can electron constitute the negative charge. So what is the constituent of the nuclei now? What is constituent of the nuclei?
P plus N.
Yeah, P plus N. That's why I'm asking. I'm asking what is the constant of nucleus? P plus N. What is the constant? What is the charge of neutron and what is the charge of proton? Proton is positive. Neutron is
No charge.
0. So 1 plus 0. So 1 plus 0 will constitute the 1. 1 plus 0 will constitute the 1, and this one is the
Negative.
what is the charge now? It will be electron. Yeah, electron. Electron will have the negative charge, which is minus 1. So the nucleus will constitute now 0, 1. This one is minus 1. So it should be 0 plus 1, 1. This one is minus 1. So the total charge is now 0. Total charge is 0. Yeah, total charge is 0 because the electron due to presence of electron neutrality. So what is the charge present in the thing? What is the charge present in the nucleus? Will be so how the electron. Now we have to go to the last motion, etc. Why? How the electrons in the outer orbit is stable? How the electrons in the outer orbits are stable?
Due to the attraction force.
Due to force of attraction. The force of attraction of this nucleus, if it is the force of attraction of the nucleus is due by the electrons. The force of attraction between the nucleus and electrons, hence the atoms are stable. If it is not stable, what will happen now? If it is not stable, what will happen? It become unstable. So if it's unstable means what will happen? If it is unstable means what will happen? It will not show the stability. It will not show the stability. So nothing is stable. All the atoms that you are processing, you should have. Example I am taking as example. You can example is any example you can take. What example we can take? I will not take example. You have to tell me what example I can take.
Sodium.
Not sodium. Not sodium. Okay. Not sodium. Any two example you can take. Any example of elements, you just take any two example. Compounds. Stable. Unstable, you not take example at all. Everything, if it's unstable, you can't study its physical property, right? Noble gases. Yeah, noble gases is not a one. We can go to hydrogen and oxygen. Oxygen gas, you know, you are having the well-known established oxygen gas. Then hydrogen gas. Hydrogen gas, it's not available that much outside. So we have to prepare it in the lab. Okay. Then you have to produce. Then you have to give for the then you have to give for commercial use. So where will be, do you think that hydrogen gas will be used? Notably, hydrogen gas. Hydrogen. Hydrogen gas. Where it you think that it will be used? Oxygen. Oxygen you know very well. It's available all over the world. But what is the specialty of the hydrogen? Hydrogen gas.
Nuclear fusion.
Not that's different. Nuclear fusion you can take it as example. Okay, you can take it as other than that. Do you have any example? If we don't any other example, we go for nuclear thing. There is only hydrogen will be there because hydrogen, deuterium and tritanium. So exactly that's application of the things. Anything you can take. Okay. So what is other than you can take things for heating of the metal. For heating of the metal, you need the oxygen. Then not all the metal will. Not all the metal will melt. Okay. For example, all the metal, which is a metal that I mostly use is iron. For reduce to reduce its boiling point, what they will not boiling but melting point. The melting point of the metal, what they will do, they will do heating in presence of hydrogen. Okay, so that the process will be fast. That's one of the many big application of hydrogen. What they will do, they you know right. What is what for they will melt for iron? Iron. What is the purpose of iron? Iron. Tamil la solla. இரும்பு. இரும்போட application என்ன? இரும்போட application நிறைய. It's not a no batteries la பொறுத்தவரை. No, factories தான் they will do. என்ன factory?
Steel factory.
Ion factory.
Wherever you go, everything is made up of iron. Car industry, bike industry, etc. Plenty of opportunities there. I want to quick it fast. I want to do the process fastly, very fast. So what I will do, I will process of I'm cutting the metals. Okay, metals in presence of hydrogen. If I do the process in presence of hydrogen, what will do? It will melt the quickly the metal will melt. Okay, otherwise it will take the time will be faster. So like this various applications there. So two gas we can take, hydrogen gas, oxygen gas. It should be stable. It should be stable, then we can study the physical. If it is not stable, can we study the physical property? Nothing can be studied. So that is so now it comes for the here. So if I take this, if I go for this process, I am taking two hydrogen. Okay, what is the hydrogen? H2. This one is O2. So how many electrons is present here? How many electrons is present here?
2 electrons.
2 electrons. Here it is 2 electrons.
16.
16 electrons. So number of proton is present here is in hydrogen, and number of proton present in oxygen.
216.
260. Yeah. So here it is 2. Here it is 60. So that means the electrons are rotating the nucleus. That relates to stability of this stability of the compound. Here also the stability of the elements, and here also the stability of the elements. So the elements or compounds all are stable due to presence of elements and elements, compounds. Everything is stable due to presence of the elements. Whatever present here, all are stable due to force of attraction between the electron to the nucleus. Force of attraction between the electrons to the nucleus. So the force of attraction which decides its fate, whether the compound should be stable or non-stable. If it is stable only, everybody needs to be stable. Everybody needs to be stable. If it's unstable, there is no application of it. And the mass of neutron is 1.00866 U, which is 1.6749 into 10 power minus 27 kg. Mass number is equal to atomic number is equal to number of proton. Neutron number is equal to number of neutron. Atomic number is equal to number of protons, and mass number is equal to Z plus N, which is total number of proton and total number of electrons. So mass number is equal to total number of protons and electrons. So mass number is equal to total number of electron and proton. Atomic number is equal to number of protons. Size of the nucleus. Size of the nucleus means this size. This size. So if this is size of the nucleus. Okay, size of the nucleus is given by R equal to R0 A 1 by 3. A is the atomic number. A is the atomic number. No, A is the mass number. A is the mass number, and R equal to R0, which is the the radius of this things is radius of the nucleus is given by R0 into A into 1 by no why R equal to R0 A 1 by 3. So R is the radius of the nucleus. Okay, R0 is the R0 and A is the what is the number? A0? No, A is a mass number. R0 is the constant value, which is 1.2 into 10 power minus 15 meter. So this is a constant value, and this is this constant value versus A. What is A now? Mass number. So if the mass number varies, this one is the radius will be, but radius also varies. So the mass number, for example, any two mass you take, what is it? Hydrogen and oxygen you can take. What is hydrogen mass number? 1. Atomic mass number of oxygen? 16. So if I substitute here it is 1, here it is 16, this one is constant. So what will happen to the radius of the nucleus? Which will have the higher radius? Oxygen. Then theory of relativity, I already explained, no? They given here, by which it comes, where it comes? Theory of relativity, it comes in the photoelectric emission. Units and measurement. It also comes in the photoelectric emission. Okay? Now it comes as E equal to mc square. So I don't know why they gave for here mass equal mass energy. Okay. It should be okay. We'll discuss in the mass energy in the nuclear fusion process. Then we go for nuclear binding energy. Nuclear binding energy is the one which holds the neutron and proton. So if what are the possibility here now? Neutron to what is 0 here and what is 1 here? First you tell. What is 0 here? What is 0 here? What is 0 is here and what is 1 here? Who is telling? Who is telling what is 0 here and what is 1 here?
0 neutron, 1 proton.
Yeah. What is 0 and 1 here? So that is the nucleus has only 2, neutron and proton. Okay, the 0 is neutron, 1 is proton. So that means the force of attraction between proton and neutron. So the force of attraction is proton and neutron is there. I want to break it. Okay, I want to break this. I want to break it. So if I break it, what I will get now? If I break the nucleus, what I will get now? Who is coming? Who is telling? If I break the nucleus, what I will get it? I am breaking into this is the nucleus. Okay, this is the nucleus. I am breaking into. I am tearing this book. Okay, into 2 parts. Which is nucleus? What I will get now? Proton and neutron. So the energy that is needed to break this nucleus, that is called binding energy. Nuclear binding energy or nuclear binding energy. So I need to break it. Okay, I need to break this nucleus. So that is called nuclear binding energy. So nuclear binding energy. That means if the I'm for now we go for same thing, hydrogen and oxygen. How many how many protons it will have? How many protons hydrogen will have? One. How many proton oxygen will have? 16. So if that is case 1 and 16, the number of neutrons to number of proton in what is the ratio of the number of proton in oxygen, in hydrogen and oxygen? No, number of what is in hydrogen, what is the ratio of proton and neutron? 1:1 in hydrogen. First you take forget about oxygen. This is here is hydrogen, there oxygen. First you go for a hydrogen. Number of proton equal to number of neutron. How many proton is there? How many neutron is there in hydrogen? 1:1. Now you go for oxygen here, which is oxygen, which is number of proton plus number of neutron. How many oxygen is there? How many proton is there? How many neutron is there? How many oxygen? How many proton is there? How many neutron is there? How many proton is there? You didn't understand? Hydrogen, oxygen. Okay, you need to calculate for number of proton and number of neutron. Here calculate number of proton and number of neutron. Oh, how many proton is here? 1 is. How many proton is here? How many neutron is here? 1. How many proton is here? How many neutron here? How many proton?
Sir, inga neutron 0 varum sir. There is no neutron present in hydrogen.
Neutron illa in oxygen. Oxygen evlo?
16:16, so 1:1.
1:1. Okay. What is how many proton is here in hydrogen?
2. H2.
No. Hydrogen. Total hydrogen. No. 2 hydrogen plus hydrogen. H.
இப்ப இங்க 16 சொன்னாங்க 2 சொன்னாங்க.
ஆமா இங்க oxygen O. So number of proton is present and number of neutron is present here. Okay. So here how many proton here?
16.
How many proton and how many neutron? 16. 16. Okay. 1:1. Okay. So now we come for hydrogen. Okay. How many proton is here? How many neutron is there?
2:0.
2:0. Because number of neutron is 0. Number of proton is 2. So இதுல என்ன ratio இருக்கு? Here it is.
1:1.
So some ratio மாறுது இது. So if it is changed, what happened to the binding energy? இப்பதான் this is my question.
Binding energy also changes.
Binding energy just changes. So which will have the higher binding energy?
Oxygen.
Hydrogen. So Bi1, B1, B2. So B1 is greater than B2. That is binding energy வந்து for the ratio, this ratio increase ஆனா binding energy அதிகமா இருக்கும். If you see that all the energy, hydrogen will be the more binding energy. So அப்படி இருந்தா that's why in nuclear fusion, what is going on the process in the nuclear fusion?
H plus H.
Not H plus H. Hydrogen, not H plus H, H plus H plus H plus. Simple H plus H, H plus H. That is hydrogen and hydrogen are combining together. So if two hydrogen combines together, what will happen? Final hydrogen should be H2 or D2. H2 தான் நம்ம D2 ன்னு சொல்றோம். Now D2 I am taking and adding one more hydrogen. It's a H3, which is nothing but T3, which is tritanium. So that is hydrogen is converted into now deuterium. Deuterium is converted into tritium. So for that what is the process? For that combining two hydrogen, tritanium. So this is a process is going on in the sun. So I am accompanying two hydrogen and hydrogen. So it will so I need to supply what? So I need to supply lot amount of energy to carry out this. So again I have to supply lot amount of energy to carry out to get the tritanium. So what is so if I want to supply the more amount of energy, the temperature will
Increase.
it's not a temperature increase. I have to supply huge amount of energy to carry out this process. Okay. So this to carry out this entire process, I have to supply huge amount of temperature. So I have to carry out so where I will get this high amount of where I will get the high amount of energy. You understood my process. You understood my question. Binding energy is a 1. I need to split it. Okay. Binding energy is a 1. I need to I want to split it. What I want to split it is the proton force of attraction between proton and neutron. So binding energy is a 1. Either you can supply that energy to break it, or if you supply that energy, same energy, you both will combine. Okay. Now comes the problem. So now comes the problem. What is right? Hiroshima and Nagasaki.
Yes, sir.
What is the name of the bomb? Just one you take. Hiroshima. What is the name of the bomb that they launched? Huh?
Nuclear bomb.
Atomic bomb.
That only I am telling. What is the name of the bomb?
Are the place
Hiroshima and Nagasaki are the place that was devastated by the Americans, and the Japan place. Okay, Hiroshima was dropped on what is the name of the bomb that was dropped is Little Boy. Okay,
little boy.
Little Boy. Okay, what is the principle behind it? What is principle behind it? What bomb they launched it?
Atomic bomb.
Yeah, atomic bomb. Okay, atomic bomb. Everybody knows that. Okay, what is
Principal, sir.
principle behind it?
In the
Nuclear fission.
Yeah, nuclear fission bomb. That is the nuclear fission bomb. Okay, I am taking the uranium 235 and bombarding with the neutron. Okay, I am neutron. So what will happen now? Uranium 236. Uranium 236 is unstable. So when this for this and this no problem. Okay, I am taking neutron bombarding with the uranium 235. I don't have any problem. Now uranium 236 comes. The moment it forms uranium 236, what will become? It's unstable. Okay, it's unstable. It cannot stay for not more than 1 second. It will not stay for not 1 second or 1 second you can keep. Okay, after 1 second what will happen? It will explode to give its corresponding things barium and krypton. Okay, barium and krypton. Okay, barium and krypton. Then 3 neutrons. Okay, so during this process only, by which uranium 236 will convert into barium, krypton and things. So this is the nuclear fission process. Okay, nuclear fission process is the one by which the huge amount of energy will be evolved, by which it can destroy the entire city. So how many people died in that Hiroshima? 1 lakh people died. So almost 1 lakh people died because of this one bomb. 1 lakh people died, and the entire city was devastated, which is devastated. That's a devastated. Devastated means the entire city was destroyed. Hiroshima, entire city was destroyed, by which 1 lakh people died, and 100 square kilometer, the city was destroyed. So the depth is 100 kilometer. Now what is my question?
The name of the bomb.
Name of the boy is Little Boy. I told you, no. Name of the boy name is Little Boy. The place is Hiroshima, and I given the principle also. Neutron is bombarded with uranium 236, and uranium-236 will give barium and krypton. Why it is giving barium and krypton? Because this one is unstable. Once unstable, immediately it will compose to give barium and krypton. So during that process only, it will evolve the huge amount of energy. So by which it is destroyed. Now my question is, this is nuclear fission process. Then what is nuclear fusion process? Nuclear fission. Hydrogen plus hydrogen. Okay, so I need to create hydrogen and hydrogen to give deuterium. Deuterium and hydrogen is titanium. So what I am going to do now? What I am going to do? I am going to combine hydrogen and hydrogen. Okay. So for that what I am going to do is I am supplying the huge amount of energy. Okay. I have to supply huge amount of energy. So what is the energy that I needed? Yeah, nuclear. We have to calculate that. Okay, some nuclear binding energy. This much of energy if I supply, so if I supply this much of energy, it combine hydrogen and hydrogen will combine to give deuterium. Deuterium and hydrogen will give tritanium. Okay, so to carry out this nuclear fusion process, what I have to do now? Now this is a nuclear fusion process. This one is nuclear fission process. So what I have to do? So nuclear process is the one by which the temperature minimum temperature you need is 5000 degrees Celsius. 5000 degrees Celsius. So only at 5000 degrees Celsius, hydrogen will combine to give tritanium. So tritanium and hydrogen will combine to give deuterium. So to carry out the nuclear fusion reaction, what I am going to do now? I am going to carry out nuclear fission reaction. Nuclear fission reaction. So so 235 on neutron on bombarded uranium 235 will give 236. So this will give high amount of energy. So what is the temperature it can create? It destroys the entire Hiroshima and city. Okay, what is the temperature it will produce? It will produce around 5000 degrees Celsius. So the nuclear fission process will produce the 5000 degrees Celsius. So this 5000 degrees Celsius by which you can combine will help to produce the nuclear fission reaction, which is hydrogen and hydrogen, deuterium hydrogen, tritanium. Okay, so to carry out the nuclear fusion reaction, what I have to carry now? Nuclear fission reaction. So that is why I have to do that, because
to provide a huge amount of energy.
To provide a huge amount of energy, or to overcome to overcome the binding energy. This much of binding energy if I supply, either vice versa. If you supply this much of energy, the hydrogen and hydrogen will combine to produce a deuterium. Then nuclear next is law of radioactivity. Law of radioactivity tells that what is radioactivity? If I keep any radioactive material, okay, what is the radioactive material?
That emits the radiation.
Huh? What? No, emits rays. What is the example for that? Uranium, okay. Uranium, thorium, polonium. Okay, one is sufficient. Just uranium you can take. If I keep any who's Marie Curie? Marie Curie. Huh? Huh?
Found the radioactive.
Yeah, who found the radioactive material? She found the radioactive material from the polonium. So what are the three radioactive material is? Alpha, beta, gamma. So alpha is helium He24. Beta is alpha, beta, gamma. So the radioactive beta is alpha is He2 4. Beta is electrons or is a type of electrons which are beta is a beta rays. Okay. Then gamma rays is there is no officially gamma rays. It's a alpha is positive, beta is negative, then gamma is neutral. The law of radioactivity tells that delta n by T is directly proportional to n, that is number of electrons, number of atoms present in that nuclei will decrease exponentially, that is this you taken? So n0 is the total number of atoms that is present. After at time t, when it's off, it's now the what is the concentration of the molecule? When at the initial time t, when it's origin, it is n0. When it's at time 2, that is half of the time. What is the total number of molecules present? Huh? Yeah, n0 by 2. N0 by 2. That means at the half of the time it's decreasing the exponentially. So that means the number of time n0 by 2. So n0 by 2 means it decreases exponentially. When the time is decreases, immediately it's reduced to half. So when its time is reduced to 1/4, it will reduce to 1/4. So when it is reduced by 75%, this also will reduce by 75%. So this is what law of radioactivity tells that. So R is equal to R0 E minus lambda T. So R is equal to R0 E minus lambda T. That is lambda is R is the decay constant, total decay rate. That rate R is equal to R0 E minus lambda T. R is the decay rate. Okay, R0 is constant. E minus lambda is the constant value. Lambda is a constant value, T is the time. So R is equal to R0 E minus lambda T. When we started? 12.
12:58, sir.
1 o'clock. 1 o'clock. Now uranium now alpha particle is made up of He2 4. So the alpha particles are positive charge. Okay, so when the flame is where it will travel toward now? Towards the flame? Positive charge. You take the uranium material, the moment you opened it, it will emit the alpha, beta, gamma. If you take the flame which is positive, negative, 0, so where the alpha will move now? Alpha will move towards the negative of the flame, because it travel towards the positive, it will emit from the positive, will travel towards the negative of the flame. Then beta is a negative charge, so it will travel towards the positive of the flame. Since gamma is neutral, it will travel, it has no negativity, so 0 means it will travel at any pace. So the alpha E can be obtained from uranium 234. So that uranium 234 will decays to give uranium 238 will decays to give uranium 234 plus alpha. So that means you can prepare alpha material from uranium 234. Similarly, beta can be prepared from the phosphorus 32, which give phosphorus 32 for sulfur 32 plus beta. Gamma has no substitute constituents, it's just a race, that's all. It's an energy difference, that's all. Now then I tell the nuclear fission and fusion. So fission, in fission, what is the thing they will use? No. Uranium 235 plus neutron to give uranium 236 plus barium and krypton plus 3 neutrons. So this is the principle used in the bomb of that they dropped in the Hiroshima and Nagasaki. So now we go for the Kalpakkam nuclear power plant. What are they doing there?
Same.
Electricity produced.
No, what is doing this? First I am asking what is the purpose of it?
Electricity produced.
It helps in the electricity production. Okay, first. Second, so what is the second thing? What is the principle behind it?
Nuclear reactor I use panni.
Yeah, it's a nuclear reactor. It's a nuclear reactor meant for the production of electricity. Okay, so what is the principle behind it? Which compound they will use?
Uranium 235 neutron.
If I bombard the uranium 235 neutron, what is the principle they used in atomic bombs?
Nuclear fission.
If I what is the principle that used in the nuclear bomb?
Fission, sir.
Fission. What they do? What they taking? Uranium.
Uranium 235
Ah.
and neutron.
Bombarding with a neutron. If I use the same principle here, what will happen to this Kalpakkam?
Energy will be produced.
Burst.
It will burst. So the principle, that principle and this principle is different. So what principle can I use now here? What principle can I use here? So if I use the same principle, here uranium 236 bombarded with electron, immediately it will be burst. Okay, so immediately the burst. So no production, no. The Chennai will, now what happened to Chennai immediately when it's burst?
Devastated.
It will be devastated or destroyed. Entire Chennai will be destroyed. Okay. So to overcome that, what I have to do is I have to produce a controlled chain reaction. Controlled chain. So what is the difference between atomic bomb and nuclear power plant is, here it is uncontrolled reaction. What is the atomic bomb? The principle is uncontrolled. Once the ignition is started, neutron is bombarded with uranium, they will leave as such. So that chain reaction will go on in the uncontrolled reaction. In uncontrolled reaction, chain reaction. So the chain now in controlled reaction, you have to do controlled reaction here. When I go for nuclear power plant, I have to do controlled reaction. Then what happened to the chain reaction?
Nuclear shield வந்து அது ஃபுல்லா கவர் பண்ணி.
Okay, that's different.
Coolant
That's
தான் யூஸ் பண்ணுவாங்க சார், heavy water coolant.
No, that's not different. That's a design. I'm not asking about design. Now I ask about principle. What is principle behind the nuclear power plant?
Nuclear reactor நல்லா ஹீட்டா வச்சு வாட்டர்
அதெல்லாம் அதோட டிசைன் அதை நான் கேட்கல, டிசைனை கேட்கல நான்.
Reaction will be controlled.
Reaction will be controlled. Chain reaction will be controlled. Chain reaction will be controlled here. Chain reaction will be uncontrolled there in atomic bomb. அதாவது ஒரு இதுவே something you have to take material எடுத்து you have to control the chain reaction. That means number of electron is ejected is equal to number of just only one time bombardment. The output of the neutron that is getting will be 0. The number you have to take uranium bombarded with neutron. Okay, that's all. Now after that, the number of production of neutron will be should be 0. So that means I have to insert the rod. Okay, I have to insert that boron rod that will absorb all the neutron. So no more bombardment. Only bombardment will be once. Here will be once the neutron neutron is bombarded with uranium. It produces 3 neutrons. So one neutron will produce the 3 neutrons. So again 3 neutrons will produce how many neutron? 9. So 1 will be produce 3 will produce 9 will produce 27. So 27 will produce 27 into 3,
71.
71 na? 27 into 3, 30, 30, 30, 81. 27, 30 into 3, 90, 90 minus 9, 81. 81. So that means that's a chain reaction. That means 81. 27. 27 into 3, 30 into 3, 90. 3 into 3, 9. So 90 minus 3, 81. So that means 1 neutron I injected. Okay, I bombarded in atomic bomb. One I taken uranium and bombarded with 1 neutron. How many neutrons I got now?
81.
It's not 81. It's not 3. It's not 81. It's
0.
Infinity.
It's infinity. There is no controlled reaction. It's a chain reaction. Chain reaction means uncontrolled reaction. Okay. Here, in contrast, here I bombarded uranium with 1 neutron. Okay. What is the output? How many uranium I got? 3. How many neutrons I got in nuclear power plant?
0.
0. Because I kept the rod and observed all the neutron. The number of neutron produced in the output is 0. I observed all the neutrons. If there is output is just 1 neutron, that will lead to chain reaction. So that's a between. So this one is a controlled reaction. That one is the uncontrolled reaction. Uncontrolled.
Nuclear reactor shield la irundhu ஒரே ஒரு நியூட்ரான் எமிட் ஆகி வந்தா கூட full சென்னை டிசாஸ்டர்.
அந்த பிளான்ட்டை விட்டு அந்த நியூட்ரான் வந்து பம்பார்ட் பண்ணி அந்த யுரேனியம் 235 பழக்கும். ஸோ பழக்கும்போது அது வெடிக்க பழக்கும்போது என்ன ஆகும், அப்படியே ஸோ ராட் இருக்கும். அந்த ராட் வந்து அப்சர்வ் பண்ணிக்க எல்லா நியூட்ரான் அப்சர்வ். அப்படி அந்த ராடை வெளியே எடுத்தால் தான் அது வெடிச்சிடும். அந்த ராடு உள்ளே இருந்தால் எந்த ப்ராப்ளம் வரல. ஸோ இட்ஸ் டிபெண்ட் ஆன் த ராட். அந்த ராட் பேர் தான் போரான் ராட். தட் போரான் ராட் என்ன பண்ணுன்னா ஸ்பெசிஃபிக்லி தட் அப்சர்வ் ஒன்லி நியூட்ரான்ஸ் தான் அப்சர்வ் பண்ணும் அந்த போரான் ராட். ஸோ அப்போ என்ன ஆகும், அவுட்புட் வந்து என்ன, அவுட்புட் ஆஃப் த கண்ட்ரோல்டு nuclear power plant, number of neutron produced output is 0. Here it is infinity. There is no number. 1 gives 3, 3 gives 9, 9 gives 27, 27 gives 81. Like that goes on. It will to. So it will take for in 1 minute. 1 minute it will produce infinity number of neutrons. So I may bombard aite irko. So that's why it led to bomb. That's why it's called bomb. So that way it was dropped in the Hiroshima. Here it is controlled reaction. ஒன்று தான் ஒரே ஒரு நியூட்ரான் தான் எடுத்து இன்ஜெக்ட் பண்ணுறோம். இன்ஜெக்ட் பண்ணிவிட்டு அவுட்புட் என்னது, வாட் எவர் த நியூட்ரான் இஸ் தேர், அந்த போரான் ராட் வந்து அப்சர்வ் பண்ணிக்கும். எவ்வளோ நியூட்ரான், ஒரு நியூட்ரான் அவுட்புட் இஸ் டோட்டலி 0. ஒரு நியூட்ரான் கூட வெளியே ஒரு நியூட்ரான் அந்த போரா. அதே சமயம் at the same time if I take that boron rod outside, what will happen now? It will become the chain reaction. So chain reaction பண்ணி it will produce number of neutrons, lot of neutrons that will destroy the entire Chennai city. So it's totally depends upon the now. Totally depends upon what now? Totally depends on what now? In nuclear reactor, everything depends upon now. It's depend on boron rod. If you take that boron rod outside, that's all. Now we go for nuclear reactor. Nuclear reactor, how they produce electricity now? This I already told you, I think, in last class. Bombarding uranium with neutron, it produces the. I'm adding the rod. Okay, you need not worry about that. Okay, I'm adding the rod. So it will capture all the process will take place. So uranium neutron will give the uranium 236. So uranium 236 is unstable. It will give barium, krypton plus energy. So that energy is converted into, that energy is used to for what? For heat the water. Heat the water. Water vapor will be produced. So that will rotate the turbine, which produces electricity. Okay. What is the water? Normally it will be present in the all nuclear power plant will present in the all nuclear power plant will present in the either in the sea or to seashore. It will be Kalpakkam, Kudangulam, then Bombay, Homi Baba, Homi Baba in Mumbai, and what is that guy in nuclear power plant present in the Ganga river, Uttar Pradesh. It will be present in the river because they will be taking tons of liters of water. So they have to present only in the seashore or near to the river, not in the local river. It's very biggest river like Ganga. Only like river like very biggest like Ganga and Yamuna, not Yamuna, which is Indus, not Brahmaputra, which is located, which is traveling in the Mumbai, which flowing from Bhopal to Maharashtra. And Narmada. So only it should be located only in Ganga and Narmada, where the river flows, heavy rivers flows. Okay. So they will take huge amount of water and do all the process, and finally they will be converted into the vapor will be the vapor that is falling on the turbine, by which the electricity will be produced. The vapor is very hot. As such you can't leave into sea. If you leave as such, what will happen now? Huh? No. Water will be present in the steam format. Okay, that is over. The production is rotated the turbine. The current is produced. Now it is produced in the output is the sea water in the vapor format. Okay, sea water in the water in the not sea water in the vapor format. So it should be in the vapor format. What will be the temperature?
Hot.
Yeah, it will be hot. High temperature or hot temperature or 100 degree, because at 100 degree only 100 degree or vapor is the sea water will be in the vapor format. It will not be in the liquid format. So if in which format I have to leave it to the liquid format or vapor format?
Liquid format.
If I leave it in the vapor format, what will happen to the sea now?
High temperature. Fishes will die.
Fishes will die. So I have to 100 degree. If I put steam water in the water, the fishes will die. So I have to cool it, and then I have to leave it in the water. Now I have taken water from the sea. I have finished all my work. Now I'm using coolant. So using coolant, I am cooling the water. I'm just after that I am putting it in the sea. So I have taken the water from the sea. I finished all the work again. So which coolant I will use?
Helium.
Yeah, liquid helium. Liquid helium, if I put it, what I will do it, the vapor which is in the water vapor will be converted into liquid water. Then it will be put it into sea in the form of liquid. So when it become into liquid, what will be the temperature of the liquid now? Moderate temperature. It will be not 30 degree, it will be around 40 degree. 30 to 40, it will be 40 to 50. 40 to 50 also okay for not 100 degree. So now it will be around 40 to 50. You can't cool it for so very low. Okay, they will cool it, and it will be they will be sending back to the water, the sea. That's all. Now I have taken water from the sea and I have sent it the same water. I finished produce electricity also. So I finished everything. I have taken water from the sea. I have produced electricity. Once electricity is produced, they will be distributed to the state government.
Sir, and the water and the radiation
nothing will be avoided because it's outer surface. No, core la the nuclear process will take place. Adukkom in the liquid ko the water is moving above the core surface. Okay, when the core surface is there, above the core surface, before passing to the core surface, it will be in the liquid state. Once it's passed to the core surface, it will become a vapor state, because the core is now 1000 degrees Celsius. Core is now 1000 degrees Celsius. So before core it is a liquid state. Once it's passed to the core, it become a vapor state. Because so adukko radiation ko nowhere related. Entire thing will be closed in the core. So once it become liquid, once in the liquid vapor state, now it will go for the work function. What is the work function here? producing electricity, that is turbine. Turbine, it will rotate the turbine at the high speed. So when the turbine is rotated at the high speed, what will happen? It will produce the current. It will produce a current. So once it produces, once it starts producing the current, now the liquid in the vapor state. So once it's a liquid in the vapor state, I have to cool it via liquid helium, coolant using liquid helium. So once it's cooled, now it's become in the liquid. Once vapor will be converted into liquid. So once it's converted into liquid, now it will be sent to the seawater back. That's all. So in this way, the water is nowhere affected by the radiation, because the passing to the core. It is passing through the core. Okay, passing above the core. It is not passing into the core. Okay, if it passes into the core, what will happen? It will pass into the core. What will happen? Suppose if it is passed into the core, passing above the core is different from passing into the core. Passing above the core means இதுதான் core இருக்கு. So இது மேல passing above the core, இது மேல தண்ணி போகுது. Okay, here what இங்க